Good evening, ladies and gentlemen. Before we begin, I will ask that everyone comes here with an open mind, puts aside their biases as best they can, and not use the genetic or circumstantial homonym fallacies to reject my claims. Thank you. Now then, Fahrenheit versus Celsius versus Kelvin and U.S. Imperial, aka U.S. Customary versus Metric versus SI. Which is the best? Practical use and application. First, understand that we humans by nature are survivalists. We have been tuned to what we need to survive ever since the early days. As such, and contrary to what many may say, our minds have a very tough time understanding abstract realities like numbers, which is why money and counting high numbers are such hard things for humans and why we make so many simple mistakes. How much is $1,000, or what does 1,000 stones look like? Thus one must associate such things with something which has that value, say a rare $1,000 cat. But how is that relevant to a house's cost? How many rare cats is a house worth? For even bigger numbers like million, billion, trillion, quadrillion, quintillion, etc., or even those with many decimal places like 3.875619, it gets even worse. For such big and or precise numbers, one must perform math, and even if you can do the math and come to the correct answer, that truth does not mean that you can truly understand and comprehend such numbers. Our brains are tuned for survival, and as such are tuned for what I shall call survival numbers, seeable numbers if you will, e.g., how many people live in my house/hut? How many children do I have playing in the field? How many wolves must we fight to live here safely? After becoming a big enough number, it doesn't really matter anymore. Phrases and words like a bunch or more than I can count in my head do just fine. Between 10 and 10,000 charging elephants, what's the significant difference? If you don't get out of the way in time, you are going to be crushed either way. The imperial system's design allows our minds to handle measurements easily and efficiently. Never do you need to visualize more than 11 inches. With the metric system, you need to measure things up to and usually exceeding 100 centimeters. That's extremely challenging for our minds to comprehend and understand. Despite the claims made from folks who are for the metric and or SI systems, neither those nor the imperial/customary systems are based upon arbitrary numbers. The metric and SI systems are based largely upon something abstract, specifically numbers, to make conversion faster. The imperial/customary system is based upon what we actually use measurements for, visualization. Thus, the metric and SI systems are great for science and math, but they stink for everyday life. That's because of how they are designed. The metric and SI systems are designed to be easy to convert and to put into math equations. But the imperial system is designed to be the most practical in the ways which we use them the most in our day-to-day lives. In everyday life, the main reason which you need something measured is so that you can visualize it, estimate it, or compare it with something else. Is the drawer big enough? How big was that bear which you saw? How long is that road? There are situations in life in which things are communicated which require visualization. Measurements are an important element of that. If someone tells you how long a tree branch is, you need to be able to visualize that. If the weatherman says that it will be 0 degrees Fahrenheit tomorrow, you need a mental temperature reference of that to mentally feel that. If you infer from a map the given distance of your destination, you need to understand how far away that is. To visualize anything, we require a sufficient reference point. Our brains are different from our computers. Computers rely on algorithms, programs, and rigid methodologies. Our brains rely on associations. They are capable of understanding certain things, and the metric and SI systems don't take these things into account. A common example is height, the most common use of measurement in everyday life. What's his growth and such? The most common use of inches and feet is height, but the metric and SI systems are very bad with measuring people. Outside of the USA, people are measured by the centimeter, which is inefficient and terrible. Much effort and discipline is required before the brain can work with and visualize 133 centimeters. In our day-to-day lives, the centimeter is too tiny and the meter is too big, but the foot and the inch are easy to work with because they are the best ranges to measure most, if not all, things in everyday life. The imperial system is sensible. Example, extend your left arm all the way to the left side of your body with fingers extended completely and put your right fist on the center of your chest. From your left hand's tip to where your right fist is, assuming that you are an average size adult, you have made a yard or something very close to it. Your finger bone, say from a fingertip to the closest pin, is an inch or very close. There are many other examples. These units are easy because we can see them daily. Some may then say that there is nothing between the yard and the mile. Exactly. When is the last time which yards were too small for non-driving purposes? But even then, the mile isn't the preferred unit unless it's about geography, we're in geography class, or we're using maps. We use time instead because it's more effective and relevant. Distance is very relative in light of the fact that it can be affected by a number of different factors. How many hours is the typical question, so we use time as the main unit. It's about an hour away. The main thing longer than a yard which need be visualized is a building. In human history, these are relatively new. We did not have these a century ago. Obviously, feet, yards, and the meter are too short, and the mile and kilometer are too huge, so we use stories. This is the most accurate measurement for a building and is very visualizable because we see it daily. Temperature. Celsius is based upon the freezing and boiling points of water, and Kelvin is based upon absolute zero. That makes sense, right? Well, maybe if you are a scientist, but how do they help us in everyday life? When we talk about the temperature, what are we 90+% of the time talking about? The air. We want to know how hot or cold it is outside on the thermostat or in our refrigerators/freezers. This is why Fahrenheit makes sense and best Celsius. It's based, intentionally or not, upon the temperatures which we humans can tolerate. If it is higher than 100 degrees Fahrenheit or below 0 degrees Fahrenheit outside, then stay inside. That's the typical range of weather. In Celsius, that is approximately -18 degrees to +38 degrees, and it relies heavily on decimals because it's a much larger range of temperature per degree. Anything hotter than about 120 degrees Fahrenheit or colder than about -10 degrees Fahrenheit is, any way you look at it, just a number. Something which the average person can't possibly comprehend because they've never experienced it. Can you comprehend what 200 degrees Celsius would feel like? You can't, because you'd be fried. The only exception which I can think of is cooking with your ovens. Even then, it's not something which we need to really visualize or perceive. If the oven needs to be set to 375 degrees Fahrenheit, just set the oven to that number. If water needs to be boiled, heat it on high until it boils. Problem solved. If water needs to be frozen, put it into the freezer until it freezes. Problem solved. Water will never get hotter than its boiling point, nor will water ever get colder than its freezing point. Under normal circumstances, that is. So the precise temperature is completely insignificant. The Imperial system's units of teaspoons, cups, pints, quarts, gallons, etc. are based upon what one can use to effectively and efficiently follow recipes and kitchen hints the best. So unless you are a scientist, it's unlikely that you use volume measurements outside the kitchen. Also, pause the video momentarily to consider the question and chart very carefully. You get the picture? That was a pun, folks, laugh here. With Celsius and Kelvin, you have just wasted more than 50 degrees, all of which could have been put to very good use. With Kelvin, you need 3 plus digits when Fahrenheit needs only 2 or even 1. Example, freezing point, 273.15 Kelvin versus 32 degrees Fahrenheit. Next, the Imperial/customary system is easier to learn than the metric and SI system. That's right, you just heard that. All systems require some memorization and getting used to, but there are reasons to believe that the common argument that, quote, the metric and SI systems would be just as easy for the normal population to use as the Imperial system if they were used to it, unquote, is likely wrong. While there may be some truth to that, it puts a much greater strain on the brain to learn the metric and or SI systems because they are based upon things which our brains don't do well. As stated previously, the human brain works based upon associations, so the only way which a human can know how tall 133 centimeters is by memorizing something which is about that tall and associating that number with it. The Imperial/customary system fits in very well with what our brains do normally and efficiently. Sure, that would mean that we would have to memorize that 32 degrees Fahrenheit is the freezing point of water, but that's a whole lot easier than memorizing the seemingly arbitrary range of -18 to +38 degrees Celsius and what everything in between relates to. The Imperial/customary system uses what our brains do normally and automatically and allows us to project and visualize things which we haven't even seen before. Very little memorization is required for this system. Now then, the shocker part and my response to all the pro-metric/SI people who make such a big deal about conversion speed. Conversion is of little, if any, importance. Of course, in science and math and the like, conversion and conversion speed may be very significant as is precision, but in everyday life, it's of little, if any, consequence. The Imperial system was made for why we need measurements, visualization. Every unit of measurement has been made just right for a precise range. The flaw of that is that the different units don't have simple convertibility, but why would that be a necessary everyday element? Assuming that you are just a regular Joe and not a scientist or the like, in your entire life thus far, how many times had you needed conversion? Not very many, if any. If it is smaller than an inch, you use centimeters or millimeters. If it is about your hand size, the size of your laptop, or your desktop computer, or the like, you use inches. If it is too big for 12 inches or your desk, you use feet. If you're doing football, running exercises, or something similar to those things, you use yards. And if you're looking at a map which represents a great enough area, driving, flying, or going across the country, you use miles. But most folks are more likely to use time for trips and such. Each unit was designed for a precise range, and they serve those ranges very well, and thus cutting down on those overly big, small, or many-digited numbers. You need to convert almost exclusively 90+% of the time because someone wants the metric and or SI systems and talks about how great their conversion speed is, particularly on the internet. Many may say that the metric and or SI systems would be easy to learn, but those systems are based upon things which the human brain is bad at and put more strain on the brain as there are few things, if anything, to associate them with. So when someone says something like, quote, the metric system is faster with conversion, unquote, simply ask, what use would I have for that in my everyday life when I measure my height/weight, order my meat, check the thermostat, or order my good beer? If you still have any doubts about the values of the Imperial/customary system, then consider the following. All predominantly English-speaking countries which were once members of or associated with the Great British Empire or Great Britain in general. Jolly old England, dear old Ireland, the Highlands of Scotland, the Stars and Stripes of the United States of America, the provinces and territories of Canada, the land from down under, Australia, and the shores of New Zealand. Let me ask you guys something. When you go into your pubs, taverns, bars, let's just call them beer houses for the sake of my point, what do you ask for/order? You ask for a draft, pint, bottle, cup, a big cup, a mug, etc. of beer. Why so? Because those are the most common units which you receive your beer in, and it is much easier to remember a physical cup, pint cup, bottle, etc., which you can see and hold, as opposed to 335 milliliters, which you can neither see nor hold. And makers and sellers of alcoholic beverages, isn't it easier to remember and say to your coworkers/the boss something like, quote, we sold 25 barrels of wine today, unquote, as opposed to, quote, we sold 1,466.75 liters of wine today, unquote. And for cooking, what's easier in terms of numbers to follow? Warning, this is just a numbers example. Don't use this recipe in actual cooking. 10 jumbo onions, i.e. 160 ounces, 2 teaspoons of vinegar, 5.5 tablespoons of vegetable oil, 3 cups of milk, 2 quarts of orange juice, and 3 gallons of radish juice, or 4,535.92 grams of jumbo onion, 9,85,784 milliliters of vinegar, 81,3,272 milliliters of vegetable oil, 720 milliliters of milk, 1,89,271 liters of orange juice, and 11,3,562 liters of radish juice. If you want to go even further, then consider Canada. They still use the foot when doing construction, and consider England. Go into a shop and you can ask for a pound or 100 grams of cheese. Both pounds and kilograms are used for the price of fruit. Food packaging has grams and kilograms, while milk has pints and liters. The road signs have miles, but petrol prices are given in pounds, the English money system, per liter, and the engine efficiency uses miles per gallon. People usually use feet and stones for height and weight. Computer and TV screens use inches, although some have centimeters. If you study a science-based subject in school, you get the metric system because conversions are easier that way. And temperature uses both Celsius and Fahrenheit. Why so? Because it's the most efficient philosophy to measure their stuff with. Use the unit which takes the least amount of effort for and most accurately represents the intended task. Saying that any one system is better than the others is like saying that saws are better than hammers. If you mean for particular tasks, that's a different story. Just because the metric and SI systems are conversion friendly and are global, these truths do not make them better systems for everyday purposes. What if the meter is too big and the centimeter is too short? What if when you want to divide the kilogram into parts, you end up with too many decimals? What if when you use milliliters, you end up with more than 100? This is why many predominantly English-speaking countries still use some trace of the imperial system with metric. Any one system is not enough. All three serve a unique purpose effectively, and it would be foolhardy to chuck one in favor of another. Again, conversion and conversion speed are good for math and science, but for everyday life, the metric and SI systems as a whole, not every individual unit mind you, are no good. Why? Because they both have too many missing places, gaps, and/or holes in essential spots. This is where and why the imperial system and its derivations beat the metric and SI systems. Imperial and customary give us the units which we typically use for our everyday purposes. They may lack conversion power, but that's precisely the point. Outside of school, and assuming that you are not a mathematician, a scientist, or the like, when's the last time which you've needed to convert an inch to a mile or a gallon to a pint? Very rarely, if ever. If it's too big or too small for the scope of one unit, then you switch to another accordingly. Question for metric folks. Assuming that you are out of school and are not a mathematician, a scientist, or the like, how often do you need convertibility, and even then, why so? Sometimes you may need to say something like 3 feet 2 inches or 1 gallon 2 pints, but this is another advantage which the imperial/customary system has over the metric/SI system. More reference points. I am, of course, referring to the three most common units of measurement, i.e. distance, liquid, and weight. With the metric/SI system, there is only one reference point per measurement type, its base unit, i.e. meter, liter, and gram. Any other unit must refer back to that one reference point, which is likely to result in decimals or big numbers, thus being hard to work with in the kitchen and such, whereas the imperial/customary system has at least 3 reference points per measurement type: distance/height, inch, foot, yard, etc., liquid, teaspoon, tablespoon, pint, gallon, etc., weight, pound, stone, ton, etc. Having more reference points means less strain on the brain and less backtracking when mistakes are made. It's like having more road markers. So if you're not a mathematician, a scientist, or the like, why should you care about conversion speed and that the metric/SI system is, quote-unquote, the system of science? How much of the rest of your life is, quote, scientific, unquote? Programmers and graphic designers should know exactly what I mean. Simply because a programming or studio environment slash language may have a feature which another does not, that does not make the environment slash language better as a whole. Visual C and Java may be more powerful than Visual Basic, but Visual C takes 3 hours when Visual Basic needs 3 minutes, and Java requires creating objects from scratch while Visual Basic has them pre-made. It just makes more sense to work in 3 minutes and with pre-made objects for simple applications. Let's, for the sake of argument, disregard the fact that no one system of weights and measurements is inherently scientific, even if the metric and SI systems are more quote-unquote scientific than the imperial slash customary system. That does not make them better for everyday life. The USA adopting the metric slash SI system would be like buying a $1 billion microscope for reading a book or a spaceship for driving down the road. They may be more quote-unquote scientific, but they don't serve the intended purpose well at all. Does it make sense to sacrifice the inch and the foot, which are very commonly used units, for the centimeter? No, it doesn't. Case in point, we use what's useful and efficient for the situation, as we should. And for the pro-metric people, particularly the ones who are pushing for a metric United States of America, if you're going to be consistent with your metric philosophy, then you should stop using such anti-metric terms like minute, hour, day, week, month, season, year, etc., and use the metric equivalents. 60 seconds per minute, 3,600 seconds an hour, 86,400 seconds per day, 604,800 seconds per week, 2,419,200 to 2,678,400 seconds per month, 7,257,600 to 8,035,200 seconds per season, and 31,556,736, or 31,557,600 seconds, depending upon the exact decimal point you use, per year. And for those who use nanoseconds, multiply all those numbers by 1,000,000,000. So, as with the Great British Empire example, to say that the metric, SI, imperial, or any other measuring system is supreme and/or only one should be used for everything is not only untrue, but, assuming that the speaker uses more than one series/standard of units, is also intellectual inconsistency, intellectual dishonesty, and intellectual hypocrisy. So, as some pro-metric/SI people say, usually sarcastically, quote, the imperial system, such a logical, reasonable system of measurements and units, unquote. To which I respond, yes, it is. If you first take off your biased glasses and put aside your preconceived opinions and ideas to honestly research and understand the history, philosophical criteria, and original intentions of the designers of said system and the current use of said system, instead of with your biased glasses and preconceived opinions and ideas say or think something like, quote, oh, this system does not use base 10 logic, doesn't use multiples and submultiples of 10 for its units, can't convert quickly, isn't officially used in science, isn't global, and furthermore, it is different than the metric and SI systems, Therefore, it's broken and worthless, and those who use it must have something wrong with them. Now tell me, folks, who here is the closed-minded, unreasonable, unfair, inconsiderate, and intolerant one? Also, for you science folks, are not two basic scientific principles the search for new and or different ideas and possibilities, and to always remain open to new and or different ideas and possibilities, even if they contradict what you already believe? My final judgment is as follows. The metric and SI systems, with all their strict algorithms, rigid methodologies, and tedious programs, are for Android robot computer calculator machines, whereas the Imperial/customary system, with its easy access to everyday tools, kitchen hints, common distances, and quick associations, are for human beings. Of course, that was analogy and metaphor to communicate a point. Obviously, either a human or a machine can use either, but the Imperial/customary system is better for human beings and their everyday lives. Case in point, the metric, SI, and the Imperial/customary systems have their purposes, and I don't see it as a competition between them. They serve three different purposes. The metric and SI systems stink in everyday life, but are great in areas where measurements need to be extremely precise and/or where uncommon things need to be measured. The Imperial/customary system is based upon what is most efficient for the individual purposes of the people doing the measuring, while the metric and SI systems are based upon abstract things like math, so that conversions are easier and faster. So in everyday life, I suggest that we all should use the Imperial/customary system to be more effective and efficient, and that the scientists should use the metric and or SI systems for international purposes and then convert the results to Imperial/customary when informing the public. They already have to convert the results anyway, because when dealing with such large or small measurements, we have no base of comparison. So what's the big deal? Case in point, each one serves a unique purpose, thus none of these standards is quote-unquote better or worse or more scientific or less scientific than the other two. Also, as a life lesson, never automatically assume that there are only two mutually exclusive options, either A or B. First, try to learn if there is an option C. And finally, just a friendly reminder, as previously stated, no measuring standard is better than the others. Each one has been designed with a specific purpose in mind, thus it would be unfair to compare them with the intent of finding out which one is superior, like comparing saws to hammers and drills and declaring that one is superior to the others. Use one here and use the other over there and use the last one yonder. So why do people insist that there be a competition between the metric, SI, and Imperial systems to begin with when we can use them as needed? What's the big deal? Thank you.